Hello world, this is John. In this video, I'll take you through elementary programming principles. Programming is quite extensive and hence I have subdivided it into several modules. This lesson covers most of the basic skills that you need to get started with programming. Having said that, let's get started with the tutorial. We will start with the definition of the various terms that you'll come across in the programming world. The first term is computer program. How can you define a computer program? A computer program is basically a set of coded instructions given to the computer and represent a logical solution to a problem. It usually directs a computer in performing various operations on the data supplied to it. Computer programs may be written by the hardware manufacturers, software houses, or a programmer to solve user problems on the computer. On the screen is a screenshot of a program that is written in C. As you can see, it is just a set of instructions that will be followed by the computer to help the user accomplish a certain task. Moving on to the next term, programming. Programming is actually the process of designing a set of instructions or computer programs which can be used to perform a particular task or solve a specific problem. As we have mentioned, a program is basically a set of instructions. So to come up with a program, what you'll do is you'll program it, which now is that process of designing those instructions based on what you expect. Programming usually involves use of special characters, signs and symbols found in a particular programming language to create computer instructions. The programming process is quite wide-ranging. It includes analyzing of an application, designing of a solution, coding for the processor, testing to produce an operating program, and development of other procedures to make the system function. The program created must specify in detail the logical steps to be taken and the method of processing the data input into the computer in order to carry out the specific task. A computer program performs the following. First, it will accept data from outside the computer as its input. The data accepted is then processed and also stored within the computer memory. It is then presented to the user as output, and the same output is also stored in the computer for future use. So this is the basic task of a computer: accepting data from output devices which are controlled by the user. The data is then accepted by the processor where it will be processed. The processor will then present this processed data into output devices like monitors and printers, and the same information or the same copies of the same information will also be stored in the computer for future use. So this is what a computer will be doing with the help of a computer program. All of this is through the instructions written within the program. Programming languages. For one to get any program, he or she must program it. And for you to program, you need to use specific languages. So what is a programming language? A programming language is a set of symbols which a computer programmer uses to solve a given problem using a computer. The computer must be able to translate these instructions into machine-readable form when arranged in a particular sequence or order. Again, I have a screenshot of the same program that I had shown you previously. And as you can see clearly from the program, is that they're just a set of instructions that will be followed by the computer. As you can see, the program is not written in the normal language, that is the English. It's like broken English. So this is instructions that will only be understood by the computer. And as the user, you may not be able to understand it right away. Again, these instructions are not just written. They are written in such a way that the computer will be able to translate them into something useful, or they are written in such a way that the computer will be able to understand them. There are various terms used in computer programming. One is source program, 2 object code. Let's define each and every one of these terms, starting with source program. The term source program refers to program statement that the program the term source program refers to program statement that the programmer enters in the program editor window and which have not yet been translated into machine-readable form. The source code is the code that is understood by the programmer and is usually written in high-level language or assembly language. So the source code is understood by the programmer and is usually written in high-level language or assembly language. The other term is object code. This refers to the program code that is in machine-readable form or binary form. Object code is the language that the computer can understand and is produced by a compiler or an assembler after translating the source program into a form that can be readily loaded into the computer. So what usually happens is that because the computer language is a bit complicated, we usually use programs or we usually use languages that we call high-level languages, which are like broken English. So this language or these instructions, they will then be when fed into a computer, they will then be taken to a translator. Mostly it will be an assembler or a compiler depending on the language used. So the compiler will take the source program, that is what we have written in broken English, and then it will translate it into something that can be understood by the computer. So like it is translated into a source program. So rather it is translated into an object code or object program. So this object program is a language that the computer can be able to understand. So as we'll be seeing later, a compiler or an assembler will simply be translating source program, that is the program that you are going to write in high-level language, and it will translate it into object code that is a language that the computer can be able to understand. So those are terms that you'll be coming across most frequently, but basically just to differentiate them is that for the source program is that program that you write yourself in your broken English in the various high-level languages or low-level languages. While object code is that machine language, is that language that the computer will be able to understand. Now, let's try to look at language translators now that we have discussed them a little bit. A computer uses and stores information in binary form, and therefore it cannot understand programs written in either high-level or low-level languages. That's what I've just explained, that the computer uses its own language that we call binary language system, that is in binary form, that is in zeros and ones. This means that any program code written in assembly language or high-level language must be translated into machine language before the computer can recognize and run these programs. So this is where now the language translators are coming in, because the computer cannot understand the human language or any program written in high-level language. It will require a translator that will translate the language into a language that it will recognize. The computer will not learn any program if it is not translated into a language that it will understand. Or simply, it will not learn a program that has instructions that it cannot recognize. Now, what's a translator? A translator is a special system software used to convert the source code or program statement written in any of the computer programming language to their object codes equivalents. The translator resides in the main memory of the computer and uses the program code of the high-level or assembly language as input data. It changes the codes and gives the output program in machine-readable code. In addition, translators check for and identify some types of errors, e.g., syntax or grammatical errors that may be present in the program being translated. They will produce error messages if there is a mistake in the code. So translators, just as the name suggests, is that they will be translating, as I've said, the source program into object code, and in addition, they will also check for errors in your statements, in your program statements. So if when writing the program or while programming you made some errors, these errors will be identified by the translators, and in some cases the program may not run until the errors are resolved. So just like in English, where there are some rules to be followed when writing the English language, the same case with program languages. So they have some grammatical rules. They have something that we call syntax, as we are going to see, which is what governs how these languages to be written. So if you go against that, then you'll find that there will be some mistakes, and this mistake can cost you. Generally, there are three types of language translators, namely assembler, interpreter, and compiler. Something good to note is that interpreters and compilers translate source programs written in high-level languages to their machine language equivalents. And in this case, you'll find that before we had these high-level languages, programming was done using the machine language, that is using zeros and ones. So this did not require any translation because it was written in a language that the computer will understand. However, you find that this language, this machine language, is quite tricky, is quite complicated. So there came now the high level languages, which is like the language that we usually use, the English language, although it will be in a kind of a broken manner. However, again, you find that this language will not be understood by the computer, and that's why now we had the interpreters and the compilers that will now translate this language that we have written into a language that the computer will understand, and that is the object code. That's why we are saying that interpreters and compilers translate source programs written in high-level languages, that is languages that we understand, to their machine language equivalent that the computer will understand. So it's good to note that. So now, what's an assembler? So let's look at what it is and the functions. Like what does it function to do, or what does it do? So an assembler translates programs written in assembly language into machine language that the computer can understand and execute. So we usually have a language that we call assembly language that is almost like the machine language, and again, even if it is almost the same, it has to be translated into machine language that the computer will be able to understand and execute. So again, something that is good to note at this point is that depending on which language you have used, you will require a certain compiler. So if you use assembly language, you will use you're going to require, depending on the language that you are going to use to program your program, you are going to require a certain translator. So if you use assembly language to code your program, you will require an assembler. But if you code in high-level languages, you will need a compiler or an interpreter for that case. So what are the functions of an assembler? It checks whether the instructions written are valid and identifies any errors in the program. The assembler will display these errors as well as the complete source and object programs. If the program has no errors, the job control will let it run immediately, or save the object program so that it may run it later without translating it again. 2. It assigns memory locations to the names the programmer uses. E.g., the assembler keeps a table of these names so that if an instruction refers to it, the assembler can tell the location to which it was assigned. So when you start programming, you usually find that you'll be defining some terms, and you'll also be like allocating them some sort of memory. So it is the work of the compiler to assign memory locations to these names, so that if the program requires those names later, they will easily be referred to. Because it will like link to where they are. So in case it is required, it will just be referred, or the location will just be referred and the name will be found. 3 is that it generates the machine code equivalent of the assembly instructions. So it's like it will translate the source code into machine code. Usually, the assembler generates a machine code only when no errors are detected. So again, you find that in this case you have to be very keen, because if you make the slightest mistake, then you'll find that your program will not run. So that will include putting a question mark in the wrong place, putting a comma in the wrong place, not putting a comma where it is required, writing misspelled words. So that will not work. So some of the errors include typing mistakes, using the wrong format for an instruction. So the instruction should be written in its format. So again, you have to learn these formats uh, deeply and understand them, so that when you start coding, you don't make the mistakes. The other error is specifying a memory location outside the range of 0 to 2047. So usually find, again, as you are coding, you'll be specifying some memory locations. You'll be saying that this should be stored within this memory range, or you'll be allocating some memory sizes. So if you give a memory size that is outside between 0 and 2047, then that will be an error and it will not work. Note, the assembler cannot detect logical errors. The programmer knows of these errors only when the program is run and the results are produced, and the results produced are incorrect. The programmer must therefore go through the program and try to discover why an incorrect result was produced. So this is what causes what we call garbage in, garbage out. Because in some cases, actually in all cases, the assembler will not detect logical errors. So a logical error is actually an error that will require some decision making, like maybe choosing between male or female, or choosing between yes or no, or doing this based on a certain condition. So if you made an error while writing a logical program or a logical statement, the assembler will not detect it, and you're only going to detect this when the result will be what you didn't expect. So when you get an error in the results, then that's when you realize that there was a mistake in the coding. So like if you required that the program shows M if the user is male, and then maybe it gives you female, then you notice that there is a problem in your program, and then you have to get back to the code and code it properly. Interpreter. And an interpreter translates a source program word by word or line by line. This usually allows the CPU to execute one line at a time. The interpreter takes one line of the source program, translates it into machine instruction, and then it is immediately executed by the CPU. It will again take the next instruction, translate it into machine instruction, and the CPU executes it, and so on and so forth. So you usually find that the interpreter will be taking a line by line of your program statement, presenting them to an interpreter where it will be interpreted, where they will be interpreted one by one. So the CPU will again be picking the translated program statement and executing it, into useful information. So you usually find that an interpreter is a bit slow because it will be picking line by line, executing it as they appear, so this may take a lot of time. The translated line is not stored in the computer memory, so this is another drawback, that the translated line is not stored in the computer memory. So what does this mean? That every time the program is needed for execution, it has to be translated. So you usually find that translation will be happening every time the program is being used, which might make the computer to my which make the computer slow in a way. That is also depending on the speed of the processor. So that is the interpreter, and basically it will just be translating the source program, but in its case it will be doing line by line, and then the translated line is presented to the CPU where it will be executed. The other thing to note with that interpreter is that it will not store the translated information in the memory, and therefore this will mean that the program will be executed every time, will be translated rather every time it is needed. A compiler translates the entire or the whole source program into an object code at once, and then executes it into machine language code. This machine code instruction can then be run on the computer to perform the particular task as specified in the high-level program. So as I had mentioned earlier, compilers will be dealing with high-level programs or high-level languages. So these are languages that are written in English-like format. So the compiler will take the whole source program, like it will take the whole program and translate it into object code. That is a language that the computer will understand, and then it is presented to the CPU for execution. The process of translating a program written in high-level source language into machine language using a compiler is called compilation. So compilation basically is that process of translating a program written in high-level source language into machine language, and that's the work of a compiler. For a given machine, each language requires its own compiler. So as I had mentioned earlier, for example, for a computer to be able to translate program written in Fortran, so this is a certain high-level language, into machine language, the program must pass through the Fortran compiler, which must know Fortran as well as the machine language for the computer. So again, as I had mentioned, for some computers they will require a translator for like each language that is being used. That is for some given computers, like they will require their own compilers. So this is because the compiler will be understanding a specific language. So maybe if it doesn't understand that language, it will not be able to translate it, and maybe that's why we require a compiler for each language in some computers, just to help in translating these languages into a language that the computer will understand. The object code file can be made into a fully executable program by carrying out a linking process, which joins the object code to all the other files that are needed for the execution of the program. After the linking process, an executable file with an extension of .exe is generated. This file is stored on a storage media. So unlike the interpreter, a compiler will like store the translated program. Like it will be able to store the object code such that if this is required, if this executable file is required, it doesn't need to translate again. The compiler doesn't have to translate again. So the compiler will just translate once. The translated program will be stored in the computer storage media, such that if it is required again, it will be referred to, and it will actually be stored in the computer as an executable file. An executable file usually have an extension of .exe. So what the compiler will do is that after translating the source program into object code, it will then again do what we call linking, or joining the object code to all the other files that are needed for the execution of the program. Because for the program to be executed, several files are required. So in the linking process, all the files that are required for the execution of a certain program will be linked together with the object code. These are the instructions that the user load. So they will be joined together and they will be stored in the computer, of course, for future use. So if in any case these program statements are required, they will just be referred, like the execution file will just be referred. Points to note is that the job of a compiler is much more difficult than that of an assembler, in that a single statement in high-level language is equivalent to many machine instructions. The format of an assembly instruction is fairly fixed, while high-level languages give a lot of freedom in the way the programmer writes statements. So you usually find that the high-level languages are mostly used because they give freedom in how you write the program statements, and because they are just like the normal English that we use, the programmer will be it will be easy for the programmer rather to write these program statements, unlike the assembly language, which is almost like the machine language, which is a bit complicated. So for the assembly language, it just uses what we call mnemonics, which are just like words that that represent the machine language. As you are going to see, we have words like and, we have words like subtract, which will just be short form of certain words. Like for add, it will be for addition, maybe sub will be for subtraction, and so on and so forth. So instead of writing the whole word, you just write it in short form. So we usually call them mnemonics. But again, if you just make a mistake in writing them, or you write the long one, or you write it in the long way, you find that the program will not be executed, or it will even not be translated. The functions of a compiler will include identifying the proper order of processing, so as to execute the process as fast as possible and minimize the storage space required in memory. So the processor will be following a certain order in processing the information. So it is the work of the compiler to define this order of processing. The other function is that it allocates space in memory for the storage locations defined in the program to be executed. Yeah, just like the interpreter, the compiler will allocate space in memory for the storage locations defined in the program to be executed. It also reads each line of the source program and converts it into machine language. So again, it will do its main work of translating the source program into object program or language. Linkers and loaders. So we have mentioned that while the compiler is creating an executable file, it has to link some files that are required in the execution of a certain program with the object code, and then the file is stored as a .ex file or as an executable file in the computer memories. So you can be asking yourself, what are linkers and why do we require to link programs together? We also have loaders that will be in a way helping in this. So computer programs are usually developed in modules or subroutines. That is, program segments meant to carry out the specific relevant tasks. During program translation, these modules are translated separately into their object or machine code equivalents. So now you understand that with a compiler, as we said, it will be like picking, the whole source program and translating it. But you find that there are some programs that will be written in modules or in subroutines. So in this case, the compiler will be translating these modules or these subroutines separately. But remember, all these modules represents one program. So it's one program, only that it is written in different modules. And because they will be translated separately, we will require linkers to link these modules together, so that all the modules work as one entity. The linker is a utility software that accepts the separately translated program modules as its input and logically combines them into one logical module known as the load module that has got all the required bits and pieces for the translated program to be obeyed by the computer hardware. The loader, on the other hand, is a utility program that transfers the load module, that is the linker output, into the computer memory, ready for it to be executed by the computer hardware. So now you can see the link between linkers and loaders. That while the linkers are combining the separately translated modules, the loader will be like transferring the load module into the computer memory for it to be executed by the computer hardware. Moving on to some other terminologies, syntax, as I had mentioned earlier, while you're programming, you have to use some special sequence or you have to follow some certain rules. So, and as you find with each programming language, it will have special sequence or order of writing characters. The sum syntax refers to the grammatical rules which govern how words, symbols, expressions, and statements may be formed and combined. So just like in English, as I had mentioned earlier, or with any other language, there are those rules, there are those syntax that will govern how the program will be written, or how words, how characters, how symbols will be written. And if this is not followed, if this is violated, then you find there will be what we call grammatical errors. And in some cases, some may be very bad, such that it may not be able to, the whole thing may not be understood. So in programming languages, it is also the same case, and this one is actually even very serious, because if you make the smallest mistake, it can cause the whole program not to work. So these rules that govern how words, how symbols, how things are to be maybe formed or written is what we call syntax. Moving on to another term, Cymatics. Cymatics and Cymatics, they are rules which govern the meaning of a syntax. So we've said that syntax will govern how words, how symbols, how expressions will be combined, and all that. But again, for any rule to be followed, or for any rule, it has to have a certain meaning. Like, why do we have to write it like this? Why should it be like this and not like that? So we have now what we call semantics, which govern the meaning of a syntax, or which governs the meaning of a certain rule. This dictates what happens or takes place when a program is run or is executed. We now come to the end of our module 1, and in our module 2 we'll be looking at levels of programming languages. See you in the next module.